Hi everyone, let's start solving today's LeetCode Daily Challenge question 649 Dota to Senate. So today's question is a bit of tricky one. So uh, we'll see the question step by step and try to build the intuition by solving different examples. So I think by solving different examples we can come to a solution, and you also able to build the intuition. Okay, so these are the two main points of this question. So the first one is ban one senator's right. A senator, you can think of a person who works for government, so can make another senator lose all his rights in this and all the following routes. So basically it means like one member of the party can revoke all the rights of the another persons which belongs to different party. Okay, announce the victory if the senator found the senators who still have rights to vote all are all from the same party, he can announce the victory and decide on the change in the game. Okay, and this is also one of the main point. The round based procedure starts from the first senator to the last senator. Okay, in the given order. Okay, so we have to maintain the order. This procedure will last until the end of the voting. All the senators who have lost their rights will be skipped during the procedure. Okay, so no worries. Let's start with taking an examples. Okay, so R and D, there are two members. So first members belong to party R and second one belong to party D. Okay, so as we have to follow the order, so this person, as this have the authority now and can take the action, this can simply revoke the rights to rights, lose all his rights. Okay, so R can revoke all his rights, the D members. Okay, now the round 2 contains only the R in the string, so R can announce the victory as per the second rule. Okay, so this is the basic example. This was example 1. Okay, let's see example 2. So what is example 2? Okay, let's take the example 2, which is RDD. Okay, to better understand, let me write it as R1 D1 D2. Okay, so what I am trying to say, like as we have to follow the order, R1 can revoke the access of either D1 or D2. Okay, so this is the round 1. So R1 revoke the access of revoke all the rights of D1. Okay, so R1 D1 is gone. Now D2 is part of the string. Now D2 what can do? D2 have the authority now. Now D2 revoke the right of any remaining member which is belong to the another party. So D2 can revoke all the rights of R1. Now D2 remains in the string, so D2 can announce his winning. So we can return dire in this case, and if the R only belongs, so we have to return radiant in this case. Okay, so in this case we have to return radiant. Okay, let's take one more example. So example 3. Okay, so I think we are building up a little intuition by solving. Like we have to segregate the party members because we have to take action on that. But let's see this. Let's try to solve this example as well. So for simplicity, what I will do, D1 D2 and R1 R2 and R3. Okay, so D1 have the authority now as per the order. So D1 can revoke the access of any party member. So R1 he will do. So D1 can revoke the rights of R1. Okay. So D2 is gone now. Now D2 have the authority. Now D2 can revoke all the rights of R2 because that is the as per the order R2 came. Okay, now we do not have R1, we do not have R2. Now the authority came to R3. Now what R3 will do? R3 as you can see, now we also have D1 and D2 in the picture after he revoked the access of R1 and R2. So R3 can revoke the access or all the rights of D1. So D1 went out from the picture. Now we have in the now remaining one is, so R3 revoke the so in this order I am saying. So let me try to write it. So D1 revoked R1 and D2 revoked R2 and came to the authority came to R3. R3 revoked the access of or all the rights of D1. So now D2 remains and R3 remains. After that, authority came to D2. Okay. So D2, what D2 will do? D2 will again revoke all the rights of R3. Okay. After that, only D2 will remain into the string and can announce his victory, and we return dire in this case. Okay. Let's try to see the intuition now. So as what we did, so what we need to do, we need to revoke some party members, like we have to make the decision, but after making the decision, the prior one can come back into the picture. So another decisions can also be made of. So as we seen D1, D2, R1, R2 and R3. So D1 revoked R1, but D1 come again after making the decision, because R3 can again make the decision on D1. So kind of with data structure we can choose here. So we can choose something like Q. Okay, so what we will do, D1 and D2. Okay, so can we use a single Q? So if I use a single queue, I have to make the instant decision and I have to remove all the things. Okay, so D1 came into the queue, D2 came into queue. Now R1 came, so D1 and R1 should be gone, and R2 came into queue, so D2 and R2 will split up, but R3 remains. So in this case R3 is winning, but that is not the expected one. So what we will do, so we will maintain one DQ and one RQ. Okay, so let me write the index 0, 1, 2, 3, 4. So when D came, so I will be inserting the index 0, then 1, and RQ will contain 2, 3 and 4. Okay, now we have to simulate all the rounds what we discussed above. So we simulated like verbally, but the same thing we have to do in the code level. So what we'll try to do as per the algorithm, so we'll fetch the first element from both the queues. So 0 came and 2 came. Now who is the so 0 is the smaller index, because as per the order, and 0 in the index of DQ, like it belongs to the dire party. So 0 can revoke all the rights of 2, but 0 can come again into the queue, because another decision can be made up to him or on him, or he can made. Okay, so now, but how we need to insert 0 plus the length of the string. So string length was 5. Okay, so 0 plus 5. I will insert, I removed both 0 and 2, but I need to insert DQ again because that is a smaller one. So 2 is permanently removed, but this D1 should come into the picture again. So 5. Okay, now 1 and 3 came. Okay, so 1 and 3 came out of the queue. Now 1 is a smaller one and prior one and can revoke all the rights of the like the next senators of the another party. So 3. So 1 revoke all the rights of the third index one. So 3 should be removed, but 1 should come inside again in the queue. So 1 plus 5 is equal to 6. So 6 will come inside. Now now we have 5 and 4. So we have 5 and 4. Who is the smaller one? Now you can see this is R3, and R3 can revoke all the rights of D1. That's why we added plus n here to simulate the same thing in terms of index. So 4 can revoke all the rights of 5. So 4 will come again in the queue, 4 and 5. 5 will be permanently removed, but 4 will come again into the queue as 4 plus 5, which is 9. Now 6 and 9 came out. 6, 9. 6 is from Dyer and 9 is from Radiant. So 6, as 6 index is smaller, so 6 can revoke all the rights of the party member who came later in the order. So 9 will be permanently removed, and 6 will become 6 plus 4, sorry, 6 plus 5, 11. Okay, so 11, and at the end which queue has the last member should be win. Okay, so let's see the code base of this. Okay, so I made two queues. This is DQ and this is RQ, and both the queues have I added the index. Okay, if the character is D, then I added that particular index into DQ, else I added into RQ. Okay, now we have to do the same thing. We have to simulate the rounds while any of the queue is not empty. So first I fetch all the indexes from both the queues, and any index which is smaller can revoke another party members or another senator's right. So whose index is smaller, I am adding back into that queue. If R index was smaller, so I'm adding back into the RQ, and else I am adding back into the DQ, but I am adding N to maintain the order again. Okay, and the N based on the queue size or the last senators remained in the at the last after performing all the rounds, I am returning the answer. So let's discuss the time complexity. To generate this, this will become order of n, and how many rounds we can play. So in the worst scenario, what can happen? So the string contains half R and half D, something like that. So this is the worst case, like something like this. This can be the worst case, correct? Half people belongs to different party and half people belongs to different party. So they can play the game like revoking the rights, and yeah. So let's suppose like I am dividing the queues into n by 2 and n by 2. So what will happen after every round? It is getting shortened, because I am one member I am permanently removing from the queue. So the queue is getting shorter from n by 2 to n by 8. So which is nothing but log of n base 2. Okay, so the time complexity will be order of n log of n base 2. So that is the time complexity, and space complexity is nothing but order of n by 2 plus n by 2 is n in the worst scenario. Okay, so that's it. If this video helped you, so please like and subscribe to my channel. Thank you so much, guys.